And we are back online. Okay, live on Instagram, and I think we will be live on stream. Okay. So yeah, back online. Here we are. And we have a lot of things going here. Why so many elements? Yeah, where was I? I was here. So I was here, and this, and I need to check this. And I think we need a little bit of music. Let's go back with the same playlist. Okay. So yeah, I know it's a little bit late for the second part, but we've nearly streamed for a few hours. So I need to click stop because I think I've activated the export capabilities. So yeah, jazz, tea, seems good for me. So yeah, we've explored this little guy here, this little furry guy, and we had a little problem with it. It's quite good, in fact. I think it's good. For an experiment part, it's good. But we had some... I saw a little bug somewhere, which I think might come from the way that we are using a transparent cutout. So we have this, like we see it here. So as you can see, here we didn't see it, but we see it here. So you will see, maybe we can simply deactivate in our Neo here. Let's say a speed of 0. Let's try. Okay. So if the speed of 0, because we get the rig, I think this is why. Let's say speed of 0, 0, 1, just to have a speed, but okay. We don't see any problem here. So why do we have this little guy here with a problem? If I say 1, as you can see with value of 1 here, we can see it is we have a little problem on the shadow. So I think I've already had a little problem with this lately, but I don't remember. It might come from the transparent. So let's start by duplicating everything. So this is the Sen 1114. So again, I will duplicate everything from the script to the materials. So let's try again. So Thirteen, 13, and 13 would be 14. Okay. Oh, this one is okay. Now this one. So the GPU mesh controller goes here. And now this. So the max instance we don't need to set up because it's set up by our controller. The mesh we use in our geo, I think we use the third. No, the spike third. So it is the spike third. We use the mean. Oh yeah, we've set the same scale for everything, and we also set some random position. Let's put some color, and we'll also duplicate. Let me check. Do we need to duplicate the same shader? Right now I think we will simply use the same compute shader. This might be enough. So, but I will duplicate it because maybe we will try to change some value, but first it will be the same thing as the old one. And because we will simply change some things on the material, we will duplicate this and create a new materials. So two things I want to check. First thing is I want to check why I have this basically I want to check why I have my problem with this shadow and ambient occlusion. So this is basically what I want to change. Yeah, okay. And the second thing is I've said it during the previous stream today, is adding some emission, a light emission on the fur. So basically we have a board here with the shell fur. Okay, so this is basically some shells which are extrude from the normal direction. If we don't take the gravity or anything in consideration, and if we have the fur multiplier, which is 0, 0, 1, 0, 2, 0, 4, 0, 3, 0, 4, 0, 5, etc., etc., to 1. So it might be possible to have a light going based on the fur multiplier going from 0 to 1. So it might be possible to basically have light traveling from the base of the fur to the tip of the fur. It might be really beautiful to have some kind of, yeah, you know, lighted fur, giving some more, what can I say, that's, yeah, giving more behavior to the fur. So I want to add various things. Okay, so I will need to duplicate a lot of little things here. So this is basically this one, so no problem. And if I put this here, and if I open my script here and recompile everything, okay, so before it's nearly 11 p.m. so I'm really late on this one. But hi Salvador, how are you? Happy to see you here. So basically, on the first iteration of the fur shader, we use a transparent shader with some fade, and and this is why we got this cotonous effect. Let me show you this cottony effect, woolly effect. It's more accurate. So yeah, the first fur. So we had some woolly effect because we use an alpha blending, and we will use alpha fade, etc., etc. So basically, it was really interesting, but I was not satisfied by the way that we can see the underlaying shape under the element. So it's really cottony, it's really woolly. I like that, but I wanted to get rid of the sphere under this one. So for that, I thought it might be interesting to simply, oh yeah, we've made some various things, to simply change things by not using alpha fade, but using a cutout. By using a cutout transparent shader, as you can see, it's not woolly. The fur is more thick. Also, the counterpart is, now we can see more the shell. So because I extrude a lot, we can see a lot more the shell. And this is not fade a lot, so it might be interesting to create a new post-process effect at the end to simply try to denoise everything and something like that. So that was my my second part. But we had our little problem here, which was basically having a problem specifically on some shadow parts, which you can see here. We will see it. We will see a little dark area popping. Now we can see this little dark area, and if I re-enable, for example, the ambient occlusion, you can see a lot more the dark area which is here, which I think is basically based on the position of the sphere at the first frame. So a way to change this would be to change this shader and change the Q. So I'm thinking about changing this part. So maybe I would have an opaque shader, so the Q would be geometry, so it might not be a problem. And we will put an ignore here, and instead of using the cutout, which is here, we can use the clip value. So the main idea is to discard the pixel, which will give us the same idea on the cutout. So it's really interesting. We've used the discard method on the second iteration. If you remember, it was the way we this is the way we used in order to simply fade out an opaque shape without having to have all this problem on the Z sorting. So let me just check. So the discard method is a way to simply say this pixel, we will not see it. So basically how it works. Oh, I still have Monster Inc here. So let me just okay. So everything will work on this little guy here. Okay, so we will use the 14. So in our whole iteration this is changed. I really love the way that we can select everything. And now we will use the 14 here, and instead of simply say that we use the alpha, okay, we can use the alpha of course, but we can simply clip this alpha by simply saying something like that. So now at the end of this one we say we will clip o dot alpha. I think is that Unity shader discard. Let me check. Okay, let's try our little shader. We might have the same result, but with an opaque shader and without any problem on the alpha 13. This card can be really useful, especially when you don't, like me, don't want to work with alpha shader, because managing alpha can be a pain in the ass, especially in real-time 3D graphics. Again, compiling script might be a little bit long at first, but we have some nice music here on Instagram. And I need to find a way to have some music on Twitch also. So okay, so let's check if I was right about the discard function. I was quite right. Do I use the good shader or not? I hope so. Yeah, this is the good one. So we still have this little guy here, but the Wall-E effect is still the same, and we use a discard, so it's very interesting. So maybe I can get rid of some part of the elements. Okay. So now, as you can see, the discard is basically the same system. I'll try this one to make a big furry man. So we still have this problem here. Does it come from the shader? I don't know. We still have the cutout because we still use the cutout on some declaration at first. Okay, so we need to get rid of the cutout. We need to get rid of the alpha. So here we have, I don't need the cutout. We have an opaque, we have full forward shadow, so no problem. So this one we need to get rid of this. Okay, no alpha cutout. We use the discard, so because we declare the cutout, I'm not sure the discard is working because we were using the alpha, so you know. Let's check. Okay, let's check. We are on the Z right, so we're writing the Z def, so no problem. Let's click play and observe our results. And here we are. So yeah, as you can see now, the discard is not working and we still have our problem on this little system of occlusion. So in order to get the discard, we need to I'm not sure the discard might be a solution. Okay. Discard doesn't seem to be a good solution. I thought it could be, but not. HLSL clip function. We can say something like that. Maybe we can say if this is up than the cutout. Remember, we use the cutout, so we will try to use them. So if it's superior, then we will use it. If not, we will not use it. Let's try this part. Uniform float cutout. Okay. Compiling script is always, yeah, okay. Let's try this part now. Okay. So as you can see, the discard is now working. Okay. So now my furry one is basically the same as when we use the alpha value. So we can increase a little bit, no problem. We can change this if we want to change a little bit. So this is still a furry one. Okay. Okay, next. First we can change a little bit the modifier on this one to have more gravity on it. But we still have this little ambient occlusion problem. So why? Do we still have our little shadow problem? Yeah, we still have a shadow problem. So let's try to think about it for a moment. Let's open another shader, a simple one where we have everything. So for example, the 2 shader. Now we have this discard value, so no problem. We have a surface output standard, which is here, surface output standard. Not a problem. We still have the vertex position, so it's okay. We have a standard one, so this is what we have. We still are standard. We can add the shadow, for example. Okay. This one, we don't want the shadow for this one. Then, what's the difference? We have a forward base, an opaque, so it was this. Let's check. Did we solve our problem? I think so. I think the problem is solved. So it was a problem of shadowing. I think so. So as you can see now we have this. So this is correct because it's scalable and return, but beauty scale volumetric is now fixed. So if I'm correct, I don't see any error on shadowing. And the batch is still good on the speed. So perfect. So let's go back to our little guy and specifically on the art direction, because first of all we are art director and we need to make something beautiful, and I'm not quite convinced about the color. I think I'm convinced, but we have still some UV problems, etc, etc. So that's why I want to make something different. So first of all I want to have a big furry one, so let's say something like this, and maybe we can change a little bit the fur and having less fur to the base and big fur to the, but we will check this later. So something like this might be interesting. Okay, then we will need to change and to prepare using Photoshop the we will prepare the base of our texture. So first of all we will get rid of these little parts just for a moment. We get rid of the noise, we will only use the RGB, and we will use a simple fur shader, and specifically I think we will go with the black and white. So this will be fur 2. Okay, so yeah, we will go with the black and white fur, and I think our alpha is not tileable also, so you know what, we can, it's not a problem to don't have a tileable fur, but okay, let's try this one. So we get rid of this. Various things here, because we are on the shader, I need to say to you. First of all, I think I will add to the emission the cube map, just to have some different lighting based on the environment. We don't have it on the, we not have it on the two previous fur experiments, and I think it might be more interesting to basically cast light from the environment. It will give us a more ununity look, which is what I want to have. This is the first part. And the second part will be to have these little lights going from the base to the tip of the fur. So no problem, I think we know how to do that. Maybe we will work with something more simpler this time. I always said at the first iteration of our experiment that I wanted to work with color, so I will not go to I will not fall to the pitch of the black and white system, but the black and white fur might be really beautiful. So this is our little fur man, full black and white. Okay. So I said I wanted to add some more cube. So the way to do that, we made it. I think it was not today, not tomorrow, not today, not yesterday, but the day before. So it was not the 14, not the 13, not the 12, but the 11, I think. And yes, in the 11 we have this little guy here, which was the cube here. So let's add our cube first of all. Okay, this is the cube map. Let's change a little bit. So this is the based fur property. This is the behavioral fur properties with the gravity texture, the gravity text strength, which might be going here, and the velocity strength, and this would be simply the alpha discard fur property, and this is the fur texture properties. Okay, so we have our little cube here and we need to add it. So first of all, we need to go to know the world reflection and the internal data. So we'll use this here in our input. Okay, then we will simply use the sampler cube here. Okay, and we have something like that. Yes, this was the emission. We use this using the normal RGB and multiply by the global emission. So this was our main emission. So I think we will simply copy paste this. And we would add something like that, and maybe we would simply add an albedo emission, as we made in fact for the two of them. So we have the global emission and the albedo emission. So this one are here. So let me get this one and put this here, and let's take the albedo emission here. So basically we're taking the cube, the rod reflection in normal RGB. Okay. I think we're right on this one. So, undefined expected t-valid at line. This yes, this is this. I think it don't like the slash, so it cannot compile. Waiting for Unity to compile. So, does it work? And it works. And as you can see, because we already use this on another shader, we already have our little cube map here, so this is perfect. So now it's kind of interesting. If I want, we have the albedo multiplier, which is here, and which is basically it's give us nothing, but we can add a little bit of the environment occlusion, and this is kind of interesting, especially because we have the metalness here. So if I simply change the metalness here, it will define the way it behaves. Also the smoothness, as you can see, smoothness change a little bit. So okay, so maybe we want to say something like that, and let's try to find why our albedo emission does not work, because it's not on this shader, it's on this one. Yeah, because we didn't choose the proper variables. Okay, so let me just put this aside and say this. Okay, so now we can see really Okay, let's relaunch our little okay, now it's more interesting. So with 0 you can see now we can have some albedo multiplier here, and now we have something like that. Okay, sure, no problem. For example, if we use another environment like this one, you could see okay, let's find something, let's try something. For example, so this is the main reflection, as you could see, and it doesn't take the metalness value and everything like that. So we need to change this a little bit, because basically it's taking just the global emission and it's taking it as a pure reflection. So let's try to change that. So basically we have sampled the cube here with the reflection vector, so that is not a problem. Yeah, this might be the ruggedness. So let's try to find unity I'm looking for something different. Let's look into it. For example, we have this, but ST, DDX, DDY. So we have this, the sample state, the texture coordinates. So this with something with mip map. I think I want to work with mip map. It might be the mip map level. Maybe we can change a little bit this. So let's try something like that. O.emission will be equal to unity sample cube LOD. And we want our cube. We want the rod reflection normal, so that might be that. And I think this is the smoothness, so this will be the glossiness, so not the metallic, but the glossiness multiplied by the unity spec cube LOD step. Let's try this to check if it's working. I think it's an old identifier, but yeah, sampler cube. Identifier sampler cube. Yeah, I was not sure, and I was right. So everything is really defined here. Maybe we can sample a little bit. Yeah, as you can see, it's really and there is also something like that. It seems to be text cube LOD. Yeah, this is what I want. I think this is the ID because I was looking into an old Unity documentation. So because we're having that, we can simply now think something, use a linear interpolation between 0, 10, because it's the max mip map we have. Then we will use the glossiness for that. Or we can use the metallic value, for example, in order to keep everything. So 0, it will not be blurred. So if I want to be something blurred, I want to have something like at 1 it would be really blurred, and at 0 it would be unblurred. No matching 3-parameter function. It was that. Cube. So the function is good. Possible intrinsic function, but I think yeah, my function is really not good enough. So what is this value? It's a float 4. Of course it's a float 4. It's a float 3. Of course it's a float 3. So I need to say it would be a float 4, and the last value would be the mip mapping. So something more like that. let's the compilation begin. So yeah, while it's compiling, let me show you what I needed. So I've checked the world reflection vector, which is used in our text cube function in order to get the text cube function. Basically take the cube map, and using the world reflection you can simply see which text cell we need to get, and basically it say here that it's a float 3, and Unity said we can set a float 4 in the text cube LOD, where the last component of the float 4 is the mip map. So now if we click play, and now as we can see it's more diffuse as a reflection, and if I increase the metallic value, we will have something less blurry. So this is by alpha. So if I test this, now it's blurry, and now it's not blurry, not blurry. So basically I want it, so I'm moving into the map. You can see it here, in fact, on this little here. So let me just, okay. So by simply moving from 1 to 0, you can see we simply change the MIP mapping, and as the MIP map is simply blurred value, it's better. So something like that, for example. And now we can simply again adding our fur. So now we can put a little bit of crossing, and as you can see, now our fur is taking the environment as a value for its emission. So if we set a little bit, so something like, not know, 0, 0, 0, 1 or 5, for example, you can see here we have a little bit of the environment reflection, which can be really interesting. We can also add the ambient occlusion directly from our little guy here, and basically we will simply use the same elements here. So it's a way for me to simply try to get rid of the Unity look and try to have something more different. Okay, so it's time to work with our idea of lighting going from the base of the fur to the tip of the fur. So at first we will need to try something. So let's try simply to going from the base to the tip. Okay, so something like that. So we will use the time, of course. So let's say we need something like a max time for, and this is why we can simply use the confluent shader later. But first of all, we will put a max time for everything. So let's say a max time. So we basically use the same system as we used in our shader. So now the actual time, okay, so the mode time, sorry, so this is the mode time. It's basically time.y modulo the max time. So this gives us a pattern going from 0 to 2, so 0, 1, 2, 0, 1, 2, 0, 1, 2 every 2 seconds. Then we will have a norm time, and this is the value we will use. So the norm time is basically the mode time. So okay, it's a mode time divided by the max time, and this will give us a normalized value. And now we can simply say something like that. let's define something like a thickness, light thickness, for example, light thick. This could be, let's say, 001, for example. Let's say a smooth, so light smooth, this could be 001 also. Then we would have the light, and basically the light is, and we already use this kind of animation and kind of function on the previous experiment. So it's a smooth step at first of the position of the light, which is basically the norm time, okay, minus the thickness multiplied by 0.5 minus the smoothness multiplied by 0.5, so half of the value, or no, simply the light smooth, so half of the values of the thick plus minus the light smooth. The second value of this smooth step is of course the norm time also, minus the light thick. I can put some capitalize S here, okay, so minus the light thick, and the last value would be our Fer multiplier, which is here, and remember 0 is the base, 1 is the tip. Then I can multiply this by basically 1 minus quite the same value which as on the top, but instead of taking the norm time minus the thickness, we will take the norm times plus the thickness, and the norm time plus the thickness. Oh yeah, I forgot. Thickness multiplied by 0.5, we're taking only, it's the point, so if we want a thickness, so we have the center. If you want a thickness like this, so for example one thickness, it would be 0.5 on the right, 0.5 on the left, and plus the light smooth, and again this is the, you will use the Fer multiplier, okay. And now we can put O dot emission will be, we will add the light. This could be working, could be, if we haven't made any mistake, forgot any semicolon, or making any typo on our script. This might work, and we could see maybe, I hope so, a light going from the tip, from the base to the tip of the fur. So I hope everything will compile greatly without any problem. It seems it doesn't have any error, so let's try. Yeah, as you can see, we have some little, it's quite interesting in fact, having some light, so we can see the light going inside the fur. So if I increase the fur just to see a lot of the strats, for example, you could see how it's traveled the fur. And if we say this, so it seems to be working for me. We could also use some things quite different. So as you could see, if we put everything to the same value, everything looks to be a little bit let's create a little bit of difference in the fur, because I want a little bit of difference in the fur. Let's change the strength just to see how it's behaved. So now as you can see, some of the lights, because some fur are bigger than the other, some lights are traveling more with more speed. So it's kind of interesting the way it's traveled the elements. Okay, so now we can put everything inside a variable. So let's, in the fur property, we have the gravity. Let's use a new header, which would be a light behavior property. Okay, so we could have something like a max time, which is basically the max time, of course, which is a float value, and now we've set it to 2, but I will set it to 4 to test. We have light thick and light smooth, so let's use them with capitalized values. So this would be the light thickness. This would be a range between 0, 1, and at first it would be 0, 0, 1, then we will have the light smooth. Okay, so this is the light smoothness. Okay, this is basically all the value we need. Now we will take this little guy here and say we will declare them here, so they are uniform, of course. So uniform float, and now I can say this. So now I can play a little bit with the lights elements. We can also try, and I think I will try that, to base the light movement on the noise we've previously made. Might be interesting. I just see that my camera is not really on the good position for Twitch, but it's late, so meh. Okay, let's try this. So now we can play a little bit with our values. So let's say we want something like 8. Oh, and I think I haven't changed. I declared everything, but I haven't changed the value. So yeah, everything is okay, but now we will use the max time, of course, and the max time here. Okay, and now we will use the light seek. Where is my value? It's here. Light seek and light smooth. So light thick, light thick, light thick, light thick, light smooth. Okay. Do we made everything correctly? I think so. So now we can see more the stratification because of the light, but it's kind of interesting, and especially with the bloom. So we can increase a little bit the light, for example, and we can increase the smooth. Let's say 0.1. Okay. So this is something based on the time, and it's kind of interesting to see the way it's traveled far. And you can see now we have some lights traveling, and I think it's quite interesting. So we can now add a little bit of noise into it, and we have this noise gray value, so why not? How we can simply change this by using our noise gray value. This might be by simply modifying the mode time. Maybe something like that. I'm not sure about this, but maybe we can say the norm time minus equal the noise gray, because the noise gray is going from 0 to 1. So if I'm 1, it will be minus 1, so it would be 0. And if it's 0, so it might be offsetting the time, but I'm not sure if it could be a good offset. I will try. First things first, we will try this, and then we will try to simply change the noise gray value by something else. Another thing we can try is simply check another value we have available directly in the compute shader, and which might be quite interesting in fact, which is a time per instance. So as you can see, we haven't set any value, but we have the time per instance, for example, and we have this little guy here. So okay, so we might be simply change this by an is time from this one, so we will not have a linear time, and a time per instance might be interesting, some kind of more randomly elements distributed. And the last part would be to focus on the color, and I think the main idea is to not try to focus too hard on this one and try to keep something simple, because we started a little bit late on this one. Okay, so now as you can see, it's going, but I'm not sure this is what I want, because you know, it's maybe we've seen too much of noise everywhere. So let's see the proper noise, but I think the noise shape is really too recognizable. A way to simply unrecognize it will be to scale it and simply try to have a more curvy lines, you know, something like going to the bottom to the top, going from to the bottom to the top. It might be interesting, from the bottom to the top. Okay, so let's try the noisy function. And you can see it now, but again I think it will not be interesting. Yeah, you see a lot of lighting inside it. It's really not interesting. So okay, we have this max time, we have everything here, but now let's use the compute shader. So we will simply put the normalized time in the property data value. So this is this dot data dot y, because the x is for the index, so we can use this by simply put the is value of our norm time. So basically we can get rid of the layer pose use, because we tried something at it. Let's use this, and because we've passed everything directly here, we can simply say that the norm time here is simply now equal to in.data.y. So that might give us a more organic look. So now you see it. Basically the light, look like the light is going inside. I'm not sure, but it looks like it's going inside. Yeah, it's going inside. Why does it going inside? Maybe we have a ping pong. Yeah, we have a ping pong light. This is why. This is why we simply take the norm time. This would be better. So we wouldn't have any ping pong value. And we can add a little bit of, not add, but change the time, because the time is the max time is really big. So something like minus something between 2 and 4, for example, just to have more elements. And if you want less time, because the time is really interesting, but let's say we want something like going from 0.5 to 2 to have something really speed up, you know. So now it's more interesting. Okay. So two things. First of all, we can multiply this light value by the noise if you want to simply not have all the lights on all the shapes. And then we can also try a little bit to add some randomness directly here. So my main idea is to simply taking a random value based on the loop and an instance. So let's say called random. We have a random per instance, but we will change random per loop, which is equal to the random, let's say random 3, and we will take different value inside of it. So the first value will be the loop, because we want something to change every time, so we will use the loop. The second value could be the index, why not? And the third value could be the random per instance we pass over the data.w component. Okay, then we can simply say something like that. If this is, let's say we want, I don't know, 50% of chance of having some explosion of light inside of it, or 25%, we could say something like that. So let's say if this is, for example, greater than 0.5, then the is time would be equal to 0, so no, or minus 1, for example, so no light. Okay. So now we have only 50% of chance to have some lights casting over each instance. If we want to reduce this, we can simply say if it's upper to 25. So now we have only 25% of chance to have some light explosion inside the shape. So you know, now it's a little less. Okay. And if we say it's simply bigger than 0, for example, then there is 0% of chance of having lights. So this is the idea. So let's say 25% might be good. And also said that it might be interesting to multiplying the light by the noise gray value, just to add a little bit of randomness into this world. A little bit of noise, in fact, into this light. We will simply get nearly the same results as the old one, but I think I will try to tweak a little bit the value of the multiplier in order to get some nice curve and a non-recognizable noise. Okay. Doesn't seem to have changed. Let's augment the probability of having more. Let's say it's up to 1. Okay, and now we will reduce, don't get this, and we will set a time which is fixed. I can also get rid of, but I will clean this later because the shader is a little bit too. Okay, now we will simply set a time which is bigger just to see the noise. You can also fix the time. Okay, let's say the east time is equal to 25, for example, so it could be a fixed time. Okay. I think we would need some smooth step, in fact. This is the main idea. Okay, so let's don't change this part. Because if we want to change this part, we would need some more. Where is this max time? Okay. So if we want to change this part, I will need to create a smooth step, in fact. Because here I'm multiplying something like that. So for example, I could say something like a step of the noise gray. That's a smooth step. If it's up to 25 to 1, for example, of 1 minus noise gray. For example, this might be the trick. Let's see it. There is somewhere where the max time is this, so float. Okay. Oh, we've made a crash. We've reached the time when we have a beautiful Unity crash. Not a problem. Let's reopen Unity. Okay. Now let's go to our little scene, which is here. Let's click play. Now, as you can see, the light don't really goes on, so maybe we can simply change our smooth step value. Let's say a smooth step is not necessary. Let's say a smooth step might be simply change some of it. So let's say something like that. So then, yeah, it's if it's between -1, it might be the okay. Let's retry this. So it's a little bit more, but not enough. Yeah, because of that. Let's say 45 to 55. Okay, let's retry. So we can see a little bit the noise inside of it. I'm not sure it's interesting, especially because I prefer when we have more light. Let's try to change a little bit the material and see what's happened if we simply reduce the size of the length of the fur. Something like that maybe. So now it's more interesting. So now we can focus on the color. Okay. Let's reactivate our little compute here and say we want something like 25% of the time we have this little explosion over the body. And now we can reactivate this linear interpolation here based on the noise. I'm not sure. I think I would have the same thing. No, it might be interesting. Okay. Because we don't have any... Okay. I think this might be interesting. Okay. Now we can retry our little shader. I think I will go with this kind of ramp. This one is not really interesting. beautiful, this one. So let's check a little bit what we got lately. I think it's been a while since I've used this ramp, so let me try to see. We've used blue to pink, so I think this one is really interesting. This one or this one might be also good. Yeah, I think I will go with this colored one. Okay, so let's try another things. So the UV main text, we have the UV multiplier. Okay, we have the original pose here, and we will use the time. But we ramp on the UV, but I'm not sure. This one is really not great, in fact. We don't need to ramp over this. We need to ramp over the noise, in fact. If we want something more beautiful. And this could be over a smooth step of something more like 30 to something like that, for example. Let's try something like that. I'm not sure about this, but let's try this. And expecting something here, we forgot a parenthesis. Okay, now let's try. Now it has the silly look we talk about at first. So let's try to play with the fair multiplier. So I think we could get rid of the Okay, so let's get rid of this by simply say that the color is the ramp and see if it's enough. Okay, now it's more interesting. So if we put 1, you could see something like that. 2, 4, 4 it might be too big, but 2 might be interesting. And because the albedo is quite powerful, maybe we can simply get rid of this. Okay. Okay, so it's interesting. I cannot put more a little more light into it. So let's add more light, like something like 50% of the time, and then this would be the end of our little experiment. Okay. the fur has no some emission. We have some light casting into it. So I think it's quite interesting right now. So as you can see, this is the base shape, which is really not interesting, but when you start putting some fur on it, you can start seeing something quite interesting into coming to life. So this could end the experiment for November 14. Yeah, this is November 14, and this is the end of our little experiment. I think we have everything we wanted right now. We can add more strength to the gravity if we want, or less strength, but I think it might be more interesting to play something like that. Something like that is really interesting. So we can see now our little guy here with some fur following the gravity and having some light casting into it. Also it's moving a little bit according the velocity, and it's quite interesting. In fact, we have also some little movement according the noise, so why not. So that's the end of this little experiment. I hope you like it, and see you tomorrow. Goodbye everyone.